Hello and welcome to another video, this time on Stats A2 2019 and question 5, normal distribution. Normal distribution tends to be question 5 it seems, although there was an exception last year. There's no reason it has to be question 5, but they seem to sort of accept that you might want to build up to the normal distribution question. But in any normal distribution question, it's not impossible and there normally are some nice bits to it. And you might not get all the marks, but try and get, 3/4 of the marks, 90% of the marks. You don't have to get everything right to get the A star. Okay, the machine puts liquid into bottles of perfume. The amount of liquid put into each bottle, d milliliters, follows a normal distribution with mean 25. So straight away I'm thinking, okay, d squiggle n 25. Now I've got to find, well, it didn't mention variance or standard deviation there, did it? So looks like I'm going to have to work that out. Now it does give us another bit of information, yeah? And it doesn't say find a standard deviation here, but it gives it 5 marks. So in other words, what it wants you to do, it's a multi-step problem where it wants you to realise, I've given you some extra information. We can draw it on a picture as well, and it always helps drawing a picture. We know that under this normal distribution, that 15% of bottles contain less than, so that's 15%, 24.63, yeah? That's what we know. And we want to find, before we go about doing this, we want to find the standard deviation. That's what we've got to do. Now, if you're ever asked to find mean or standard deviation, or both, that's when you need to standardize. And by standardize, I mean use this funny little z equals x minus mu over sigma. Yeah? What that does, by the way, is it turns any normal distribution into what I call the standard normal, which is like the special normal distribution, which has a mean of 0 and standard deviation of 1. So z is this special normal distribution where, let me just put it, z dash n 0 1 squared. Yeah, that's what z is all about. It's called the standard normal. It's got a mean of 0 and standard deviation of 1. And x here in this formula is going to be d in mine because they've called it d. So z equals d minus mu over sigma. I have to use that in this question. Whenever you're finding mean or standard deviation or both, you have to use standardization step. So let's get on with it. I'm going to write down first, I'm going to try and write down this picture in what I would call like a normal distribution algebra, if you like. So I'm going to say the probability that d is less than 24.63, well, that equals 0.15. And then what I'm going to do is I'm going to standardize. So I'm going to swap my d for a z, and I'm going to put less than 24.63 minus the mean, which is 25, over the standard deviation, which I'll call sigma. That equals 0.15. Now I've done very little there. I've just traded this in using this formula for 24.63 minus 25 over sigma. But it's super useful. What that does is it's basically coding, which takes that normal distribution into a special normal distribution where the mean is 0 and the standard deviation is 1. Now we want to find basically how far under 0 that is, and at a guess I'd say it's like, less than 1 standard deviation, between 0 and 1 standard deviation under the mean. But we'll find out. We're going to do it with our calculator, because what we can now do, the reason why we do that is so we can go to inverse normal. And so that's what I'm going to do now. I'm going to go to inverse normal. Let me just click on it. Inverse normal is number 3 on your calculator. I'm going to put in the area as 0.15. I'm going to put in sigma as 1. And I'm going to put in mu as 0. And I'm just going to press enter, and I get minus 1.03, and I realise I was wrong, minus 1.036. So this is actually about there on your standard normal, yeah? That's what that's telling you. That's where you would get a 0.15 area, just under 1 standard deviation below the mean. And so what that represents is this 24.63 minus 25 over sigma. Yeah, and now we can just rearrange this to find sigma, because we're going to times that over there, times that underneath, and we're going to end up, you really should end up with a positive value of sigma here, or you've done something wrong. So I'm just going to do that. Okay, so minus 1.036 divided by, sorry, it's going to be the other way around, isn't it? Oops. So 24.63 minus 25 I'll do first, and I'm going to divide that by minus 1.036, and I get 0.357 for my sigma to 3 sig fig. Yeah. Now that gives you the sigma. We've still got a little bit more work to do though, haven't we? Because we've got to find K. Now, what do we now know? We now know that D is squiggle n 25 0.357 squared. Yeah? I need to find the value of K such that that is true. Well, you don't need the 24.63 here, really, although I think your calculator will work this out using inverse normal. But what I would point out is, as you know, and this is where drawing good diagrams is good, that this is 0.15, and up to this value, K, is 0.45. Well, those add together to make 0.6, and this is your K, and this is your 24.63. Yeah, so I can see how this has confused some students, but what I would prefer to do is just find K such that the probability that D is less than K is 0.6, because then my calculator will just spit out the answer. So that's what I'm going to do. I'm going to go to inverse normal, because I've got a probability and I need a K value. Number 3, 0.6 for your area. Sigma is 0.357, mu is 25. Okay, I'm getting 25.09. And it's finally done. Okay, part B, a random sample of 200 bottles is taken. They want a normal approximation. Find the probability that fewer than half of these bottles contain between 24.63 and K. Well, we already know that that probability is 0.45, yeah? And this is a binomial problem, which we're going to use the normal to approximate, yeah? Normal approximations to the binomial are what we're doing here. Let's write down the binomial situation. We've got 200 trials, and each bottle on its own, each bottle has a probability of 0.45 of being between 24.63 and K. They told us that. And so when I do these normal approximations, I normally write down my original binomial approximation, and then I say approx to y, which is a normal distribution, and then we use NP and NP1 minus P for our mean and our variance, yeah, and that's the variance NP1 minus P. So NP is 200 times 0.45. A lot to remember in normal distribution. Is you want to spend a lot of your revision time going over it. Okay, this gives us 90 for our mean, and I'm going to times it by 0.55 now, and that gives me 49.5 for my variance. But remember, make a little mental note somewhere on the page that your standard deviation is going to be that, because that's what you're going to need to plug into your calculator. Okay, the other thing to remember on an approximation question, when you do any kind of approximation, is continuity correction. Now, we want to find a probability that fewer than half. What's fewer than half? Well, half of 200 is 100. Fewer than that would be the probability that x is less than or equal to 99. Yeah? Now that roughly equals the probability that y is less than or equal to 99.5, I think. Now, why have I done that? Well, this is a continuity correction, because we're actually going from the binomial to the normal. Draw like 3 bars, yeah? This can be like 98, 99. They should go right in the middle of bars, and 100, yeah? Well, we want less than or equal to 99, and so that's actually going to be going up to the 99.5 when you consider the normal distribution is going through the middle of those bars. And so you want to actually go up to 99.5 on the normal distribution. Feels weird, but it just makes it a little bit more accurate, and you have to do it. Now I'm just going to basically key this into the normal distribution function on my calculator. I'm going to be doing normal CD, nothing weird. My lower limit can be like minus 1,000. My upper can be 99.5. My sigma is square root of 49.5. My mu is 90. Okay, and I'm pressing equals, and it comes to 0.911 to 3 sig fig. There we go. Okay, right. The machine is adjusted so that the standard deviation of the liquid put in the bottles is now 0.16 millilitres. Following the adjustments, alright, so standard deviations changed first, so let's write that down. Following adjustments, Hannah believes that the mean amount it could put in each bottle is less than 25, but we're still going to keep it as 25 here, yeah, because that's going to form our null hypothesis, and then we're going to have 0.16 squared in there, yeah. Now she thinks it might be less than 25. That's why when I'm doing this significance with this hypothesis test, I'm going to have H0 that the mean is 25, because H0 is always the old mean in hypothesis tests. H1, well, she thinks it's less than 25, so this is a one-tailed test, yeah, which means it should be fairly nice to do. It really should. She takes a random sample of 20 bottles and finds that the mean is 24.94. Test Hannah's belief at the 5% significance level. State your hypotheses clearly. Now, as you can see, I think this is actually easier than some of the other parts of the question. I don't mind this hypothesis test. I really don't. I don't think this one's going to make me think too much, because all I'm going to write next is don't forget, you always have to mess about with the standard deviation in a hypothesis test, because you've got to do it for the sample. That's going to be 0.16 squared over 20, but that means that the standard deviation is going to be 0.16 over root 20, and write that down just to remind yourself that that's what you're keying into your calculator. So what we're going to do is we're going to find the probability that we get x bar to be less than or equal to 24.94. It only looks a little bit under 25, doesn't it? Okay, let's find out what that gives us. So this is just basically a normal CD problem. I'm going to put the lower limit as minus 1,000 again, the upper as 24.94. Oh, you might prefer me to write this as well there. That's the same thing in normal distribution because it's continuous. The probability that x equals a particular value is 0. And so that's come up before actually in the exam, like for a 1 mark. You know, that is the same as what, you know, it's got exactly the same value as that. And this way you can always just keep it the same way as the alternative hypothesis. Okay, so we've got that. I'm keying it all in. I've keyed it all in. I'm now getting... let me just key that in again. Minus 1,000 up to 24.94. The standard deviation is 0.16 divided by the square root of 20. And the mean is 25. Okay, I'm getting 0.0467. That is under the significance level. Yeah, so this is very unlikely to happen. I know I'm talking about the null hypothesis here because that's what I used in my calculator. This is a measure of how likely the null hypothesis is to be true. It's a p-value, that's what it is. And so we say reject H0, the result is significant essentially. Sufficient evidence to conclude that the mean amount of perfume dispensed is less than 25. Is less than 25 milliliters, or has decreased or something like that. Yeah, because she thinks it's less than that. And that's it. Okay, I hope that was useful. I hope that makes sense. And yeah, keep up the hard work. Bye bye.